All right, so we are going to just work through the Unit 4 review. Remember, it's only over 3 days of material, right? And so the review is definitely kind of broken up it goes kind of in sequential order of how we learn the material. So you will notice that problems 1 through 16, right? I'm going to kind of write that over here, right? Numbers 1 through 16, this is all day 1 material. Okay, so talking about parallel and perpendicular lines. Okay, so here we go. This first one, it says write the equation of a line parallel. So you want to ask yourself, what did we learn about parallel lines, right? They never touch, and the reason they never touch is because they have the same slope. Okay. Also, when it says write the equation, if it doesn't tell you what form, which this didn't, we automatically assume that it's asking for y equals mx plus b form. Okay. All right, so we're going to write the equation in y equals mx plus b of the graph that is parallel to the line in this, the blue line in number 1, but it also has to contain the point -2, 1. So remember, what I always like to do is I always like to kind of keep track of all the information for my new line. So we know it has to pass through the point -2, 1. But we also know he has to have the same slope as the given line. And so we can just count the slope, right? It looks like we're going down 1, 2, 3, 4, 5. We're going down 5 and right 1. So down 5, which is a -5 movement, and right 1. So -5 divided by 1. You can leave it as -5 over 1, but I'm just going to write that as -5. Right, and so there is all the information I know about my new line. Well, I have a point and I have a slope. So that means we need to start in point slope form, right? I'm going to write a lot on this very first one, and then because it's basically the same thing over and over and over again, right? So I'm going to talk a lot about this first one, and then I'll be able to not be so specific on all the other problems. So if we have a point and a slope of our new line, we want to start in point slope form. So y minus y1, so y minus, obviously our y coordinate up here is 1, equals, we know our slope is -5, and then x minus our x coordinate, which is -2, so -2, and remember a double negative is going to change that into a plus sign. So that is point slope form. Now we just need to do the 2 steps to get it into y equals mx plus b form. Let me scooch that up as much as I can there. Right, so the step number 1 is to distribute. Right, we want to distribute the -5. So that's going to give us -5x minus 10. And then, of course, we're almost in y equals mx plus b form. We just need to add that 1 over to the other side to get the y by itself. So -5x minus 9. And that is the equation of our line. Okay. All right, and it's basically the same all the way down, right? So on number 2, we're still parallel. I like to keep a little list of everything I know about my new line. We know he has to pass through the point -2, 1 because our directions told us that up here. But we also want to be parallel to this line. So instead of giving you a graph, we actually gave you the equation, right? So remember, he's already written in y equals mx plus b form, which is awesome, right? Which means our slope is 1/2. And our line needs to have the same slope because we're looking for a parallel line. So we also want to have a slope of 1/2. Right, so there's our new line. We've got a point, we've got a slope. So we're going to do point slope form, right, just like we did a second ago. So y minus our y coordinate, which is 1, equals our slope, which is 1/2, times x minus that x coordinate, which is -2. And again, remember, that's just going to change into one big plus sign because of the double negative. So there's point slope form. Now we need to distribute and move the constant. It's the same 2 steps every single time. So we're going to distribute first. So y minus 1 equals 1/2 x, and half of 2 is positive 1. And then, of course, the last thing I need to do is add the, oh, sorry, I was thinking ahead. I need to add the 1 to get the y by itself. All right, so those will cancel. Same thing here, I'll cancel those out. And that's going to give us y equals 1/2 x plus 2. And there we go. All right, so just a lot of point slope, right? Getting it and then taking that to slope intercept form. All right, let's look at number 3. It says write the equation of the line. So I'm going to change colors here. Again, when it says equation of the line, we are going to assume that we want it in y equals mx plus b form unless it says otherwise, right? But then it also says perpendicular. All right, well, what do we remember about perpendicular lines, right? They intersect to form 90-degree angles or right angles, and the only way they can do that is if they have opposite reciprocal slopes. Right? Remember, opposite means opposite sign, like positive, negative, and reciprocal means to flip the fraction, like 2/3 becomes 3/2. Okay? All right, so we're basically doing the exact same thing we just did above, except we need the opposite reciprocal slope. And they gave us the, right here, they gave us the point they want us to go through, 4, 3. Okay? All right, so I'm going to do what I always do and keep a list of all my information for my new line because I like to write it all down and make sure I have everything I need. So I already know it has to go through the point 4, 3, right? And then, of course, up here, the line they gave me, thank goodness, so I don't have to do a whole lot of work, it's already in y equals mx plus b form. So clearly my slope of this line is 8. But I don't want the slope of my new line to be 8 because I want it to be perpendicular and not parallel. So we need the opposite reciprocal, right? And please remember, I'm going to kind of zoom in here, 8 is the same thing as 8/1, right? Remember, slope is always a fraction. So if it's a whole number, you're going to make it a fraction by putting it over 1, right? And so the opposite reciprocal of positive 8/1 is going to be negative 1/8. The opposite reciprocal. And there we have it. There's everything I need to know about my new line so I can write his equation. So again, I've got a point, I've got a slope, so we're going to do point slope form. So here we go. Y minus 3, that's the y coordinate right here, equals our slope of negative 1/8 times x minus the x coordinate, which is 4. All right, and we are just going to do the same exact 2 steps. It never changes, guys. It's the same 2 steps over and over and over again. So we're going to distribute negative 1/8. Please use your calculator if you need to, right? Negative 1/8 times x is clearly negative 1/8 x, so you don't have to really do much for that. But negative 1/8 times negative 4, type that in your calculator if you need to. That is a positive 1/2. Okay? Then we're going to add the 3 to both sides. Again, it's the same steps over and over and over again. Right, so negative 1/8 x plus, and obviously a half plus 3 is 3 1/2. So I'm going to write that as 3.5. You could also write that as 7/2 if you want to. If you are punching that in your calculator and you hit math, enter, it might give it to you as 7/2. I'll put or 7/2, right? So I'm fine with the decimal or the fraction there for that y-intercept, okay? All right, let's go to this guy over here. So let's see, here we go. I'm going to keep track of my new line info. So it has to go through the point 4, 3, just like it says right above there. And I need my slope. Well, let's see. This guy has a slope of down 2, right 3. So his slope is negative 2 because of the down 2, and then positive 3 from the right 3. But I don't want my line's slope to have a slope of negative 2/3 because then they would be parallel. So my line needs to be the opposite reciprocal. So my slope was negative, so I want a positive slope this time, and I'm going to reciprocate or flip the fraction. So I need my line to have a slope of positive 3/2. That would be our opposite reciprocal slope. And we're right back to where we started, or where we get to for every problem. I've got a point, I've got a slope, so I'm going to do point slope form. So y minus 3 equals m, or my slope, times x minus 4. And that's point slope form, but I'm going to do my 2 steps to get it out of point slope form and into slope intercept form. So y minus 3, I'm just bringing that down, 3/2 times x. And then 3/2 times negative 4 is going to give me negative 6. And again, feel free to type that in your calculator, right? And it will tell you it's negative 6. And then, of course, I have to add the 3 over to get the y by itself. And that's going to get me in y equals mx plus b form. Okay. And on the ones where we give you a graph, if you want to graph the line at the end and see if you're correct, like down 3, up 3 over 2, up 3 over 2, right? If I draw my line, yeah, that looks pretty much perpendicular to me, right? This totally looks like a right angle right here, right? Right, so you can always sketch your graph when we provide one for you. We're not always going to give you a graph to do the sketching, right? But you can always check your answer, okay? Oh, and you also want to check, am I going through the point 43? Oh, yes, I am. Here it is right here. So I am perpendicular. I am going through the point 43, right? So I know I'm 100% correct. Okay, so always checkable if you can just go back and graph it. All right. We did a lot of these in class in our notes, right? These are the determine if the lines are parallel. Again, I'm going to kind of write down parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Same slopes, opposite reciprocal slopes. And of course, neither means neither one of those things is happening. So it's just two random numbers that aren't the same or aren't opposite reciprocals. Now, the kicker on these problems is it has to be in y equals, let me just write this down. It has to be in y equals mx plus b form so that you can actually see what the slope of the line is. If it's not in y equals mx plus b form, then you cannot just pull out some random number and call it the slope. Okay, so on this one, we're going to ask ourselves, is this guy in y equals mx plus b form? Yes, he totally is, which means that 2 is the slope. I'm just going to write that down, slope of 2. Okay, so yay. Now this guy over here, he is not in y equals mx plus b form. I know some of you guys are still under that misconception that any number in front of the x is the slope, and that's only true if it's in y equals mx plus b form. This is standard form. And so the 4, the 2, and the 7, they are meaningless to me. None of those numbers are the slope. So I need to put that in y equals mx plus b form so that I can see what the true slope is. And again, it is a 2-step process. It's the same steps every single time to go from one form to another. Okay, so to go from standard form, okay, let me just remind you, up here, we went from point slope to slope intercept. So we distribute and add the constant. To go from standard to slope intercept, it's the same 2 steps, but not those 2 steps. So we're going to subtract the 4x. Your first step is to always move the entire x term to the other side. If he's positive, then you subtract him over. If he's negative, then you add him to the other side. Okay? So that's going to give me, I'm going to bring down what I have left, my negative 2y equals, Now these cannot be combined. They are not like terms. So I'm going to put the negative 4x, I'm just going to bring him down, and then that 7 is positive, so I'm just going to kick out a plus 7 off to the side. And the reason I like putting my x first is because now I can start seeing that mx plus b taking shape over there, right? But we're not quite done, right? Because we now still need to divide everybody by negative 2. Every term has to get divided by negative 2 to get that y by itself. So y equals, and then we do this, right? Negative 4 divided by negative 2 is positive 2x, and positive 7 divided by 2 is negative 3.5. Now my equation is in y equals mx plus b form, so now I can see that my slope is 2. So he has a slope of 2. My other line has a slope of 2. Let me get a little higher, right? Slope of 2, slope of 2. That's the same slope. All right, so these guys are parallel lines. All right, so I know I spent a long time talking about that particular problem, but from this point on, they all kind of follow suit from there. That's very crooked. That's going to bug me, sorry. Okay. All right, so basically it's the same thing from here on out. Okay, so hopping over here. Oh, unfortunately, these are both in standard form, so I'm going to convert them both into y equals mx plus b. So again, it's the same two steps. We subtract the x term because he's positive. Okay. So that's going to leave me with 3y equals, now these can't be combined, so I'm literally just going to write them down, negative 5x, and then that is a positive 9, so I'm just going to give him a little plus sign and kick him out to the side. And then everybody needs to be divided by 3. Again, it's the same two steps. Move the x term, divide by the coefficient in front of the y. So y equals, now I can't actually divide negative 5 by 3, so that's just going to be negative 5/3, kick the x out, and then 9 divided by 3 is 3. So yay, now that he's in y equals mx plus b form, I can see that his slope is negative 5/3. I'm going to just box that because that's really all I need to know. I don't really care about their y-intercepts or anything like that. I only care about their slopes when I'm trying to figure out if they're parallel or perpendicular. All right, let's do the other guy. Same two steps. We got to move the x term to the other side. All right, so that's going to give us negative 5y equals, again, cannot combine those. Those are not like terms, so we just write negative 3x, and then we kick the positive 20 out to the side. And then we need to divide everybody by negative 5 to get the y by itself. And so that is going to give us y equals, now if you type this in your calculator, or you don't have to, obviously I can't divide 3 by 5 and that doesn't reduce, but a negative divided by a negative is a positive, so that will turn into a positive 3/5 x. And then of course 20 divided by negative 5 is negative 4. I don't really care about the y-intercept though, I just care about this guy, right? Because now that he's in y equals mx plus b form, now I can see his slope is positive 3/5. And now it's up to you to compare the two slopes that you just found. I've got a negative 5/3 and a positive 3/5, right? And so those are my slopes, which are clearly opposite reciprocals. So these are perpendicular. Okay. All right, two more of those. Y equals 3x minus 4. Okay, luckily for us, he is in y equals mx plus b form. So yay, that means that our slope is 3. So no need to do any prep work on that one. The next one is y equals 4 minus 3x. Remember, this one is technically in y equals mx plus b form. They have just put the x term at the back, and then the positive 4 is technically my y-intercept, right? So he is in y equals mx plus b form. They just switched the term order, which is okay. So I can still recognize that my slope is -3, right? So clearly I have a slope of +3 and I have a slope of -3. Those are not the exact same, and they're also not opposite reciprocals because the reciprocal of 3 would be 1/3, right? So this is going to be a neither situation, right? Because they're not the same, nor are they opposite reciprocals. So these would be intersecting lines, but they would look something like this. They're very steep intersecting lines, right? So they would intersect, but definitely not at a right angle. Okay, that's what's kind of happening there. I will, and you can graph them on your calculator, right? They're both in y equals form. So if you wanted to throw them in your calculator, you would clearly see that they're not parallel or perpendicular. Okay. All right, the last one, we talked about this in class, y equals 6 and x equals 2. This one always stumps everybody, but again, draw a picture if you need to, if you don't remember what these types of special lines look like. When it just says y equals a number and x equals a number, remember those are very special lines. I'm going to sketch the graph though. Sorry, it's going to bother me that that line keeps going crooked. Okay, so remember, the line y equals 6 means he's only allowed to cross the y-axis at +6. So here's the y-axis, 1, 2, 3, 4, 5, 6. So here is a horizontal line with a slope of 0, right? That's y equals 6. And then we have the line x equals 2, which means he's only allowed to cross the x-axis at 2. So he is a vertical line that can only cross the x-axis at 2. Now, technically, their slopes are not opposite reciprocals, but this is the special case scenario, right? Whenever you have a vertical line intersecting with a horizontal and a vertical line intersecting, these will always be perpendicular. Just common sense, right? You got a vertical line and a horizontal line. All right, now let's go look at some more problems, very similar to the ones that we started with up at the top. All right, so here we go. Create an equation, and again, remember when it says an equation, right, we're going to assume that that is in y equals mx plus b form, unless it says otherwise. That meets the following requirements. Okay, so here we go. Parallel, right, that's our keyword, parallel, so same slope. I'm not going to write nearly as much as I have been. So I am going to keep track of my new line information, though, because I love to do that. So it has to contain the 0.72. Right, that's written right here. And it needs to be parallel to y equals 2x plus 1. Well, luckily for us, that is in y equals mx plus b form. So that line clearly has a slope of 2, and we want a line parallel to him, which means we need it to be the same slope. Okay, so again, I just like keeping track of everything I need about my new line. Same slope, going through the 0.72. Now I have a point and a slope, which means point slope form. So y minus 2 equals 2 times x minus 7. All right, and then we do our little 2 steps to get to from point slope to slope intercept. It's the same 2 steps every time. I'm going to bring down y minus 2. I'm going to distribute my 2, so I get 2x minus 14. And then we need to move the minus 2 by adding 2 to the other side. Again, it's the same steps over and over and over again. So y equals 2x minus 12. And there you have it. Okay, let's keep on. Let's see, perpendicular. So we need an opposite reciprocal slope. Hold on, let me get my new line info box going on. So they're telling us that we want to go through the point 6, -1. Okay, now we need the slope of our new line, which means we need to find the slope of our old line. Okay, so remember, this guy is technically written in y equals mx plus b form. They've just flipped the terms and they wrote the b first and the mx in the back. It's no different though, right? So he is solved for y. So his slope is -3. But we don't want our slope to be -3 because it wants us to do a perpendicular line. So we need the opposite reciprocal of -3. Remember, that's over 1. Anytime your slope's a whole number, right, that means it's over 1. So when we take the opposite reciprocal, that's going to become positive 1/3. Right, and that's the info that you need. And then once you have that, you should be good to go to your, because I got a point and a slope. So you know I'm going to do point slope form. So y minus -1, which is a positive, right, because the double negative, equals our slope of 1/3 times x minus 6. All right, now we got to get to y equals mx plus b form. Again, the same 2 steps. So we're going to distribute 1/3 x, and 1/3 of -6 is -2. And again, you can just use your calculator for that if you need to. And then I'm going to subtract the 1 to get the y by itself. So y equals 1/3 x minus 3. All right. Number 11. All right, so here we go. Parallel. So I'm going to go ahead and get my new line info box going on. So we're parallel to that line and going through the point -3, -4. But I still need to go figure out what my slope is. All right, so unfortunately, this is written in standard form and not y equals mx plus b form. So it's hard for me to tell what his slope is. I know some of y'all might be getting to the point where you can manipulate it kind of in your head and figure out what the slope is, and that's fine. But if you're not there yet, then please don't do that. So I'm going to take this equation, I'm going to bring it over here. 2x plus 3y equals 7. Okay, and I'm going to put him in y equals mx plus b form. Okay, so remember it's that same 2 steps that we were doing before. You move the x term over, right? So that gives me 3y equals, and you cannot combine those because they're not like terms. So I'm just going to put the x in the front, and I'm going to kick the positive 7 out to the side. And then we have to divide everybody by 3. So that's going to give us y equals -2/3, because I can't really do anything with that, x, and then plus 7/3. Now don't freak out with the 7/3, because I really don't care about the 7/3. My sole objective is to figure out what the slope of that given line is. So he has a slope of -2/3, but I want to be parallel to him, which means I want to have the same slope as that guy. So if his slope is -2/3, then my new line also needs to have a slope of -2/3. All right, so here we go. So y minus, let me scooch that up a little bit, y minus -4, okay, so that's a big plus sign, equals -2/3 x minus -3. And again, the double negative changes to a plus sign. All right, so that's our point slope form. We're going to do our 2 steps per usual, right, to get him into y equals mx plus b form. So I'm going to bring down my y plus 4, -2/3 x. Again, use your calculator. -2/3 times +3 is going to be -2. Okay. And then lastly, I need to subtract the 4. And that's going to give me y equals -2/3 x minus 6. And voila. All right, next up, perpendicular. So, okay, let's see, new line. And he's going through the point 8, 0. Okay. All right, so I need the opposite reciprocal slope of this guy, but he's in standard form, so I can't see what his slope is. So again, I'm going to come over here, and I'm going to write that equation, 4x minus 5y equals 2. All right, so I need to put him in y equals mx plus b form so I can see what I can see what that slope is. So again, it's the same two steps going from standard to intercept. So negative 4x, subtract your x's. All right, so I'm going to bring down my negative 5y. Please don't forget to bring the negatives down. I see that mistake a lot. That's going to give me negative 4x, and then that positive 2 is just going to get kicked out to the side with his own little plus sign. And then I'm going to divide everybody by negative 5, which is why it's so important to remember that negative. If you forget the negative on the 5, all your signs are going to be wrong, and hence the entire problem is going to be wrong from that point on. All right, so we want to make sure we're getting all the signs straight. Now, 4 divided by 5, I can't do anything with that, but I can simplify the negative divided by the negative, which is positive 4/5 x, and then that's going to give me minus 2/5 over there, which again, I don't really care about the y-intercept at all. My only concern is just the fact that his slope is positive 4/5. All right, but I want a line perpendicular to this one, which means I need the opposite reciprocal slope of this guy. Well, if his slope is positive 4/5, then my line is going to have a slope of negative 5/4, the opposite reciprocal. And there you go. We're right back to points slope form because I've got a point and a slope. So here we go. Y minus 0 equals negative 5/4 x minus 8. All right, same two steps. We're going to distribute the 5/4. Again, you can use a calculator, so no need to freak out. So negative 5/4 x is, of course, just negative 5/4 x. And then negative 5/4 times negative 8, if you type that in your calculator, right, go ahead and make sure you're practicing that on the calculator, not just taking my word for it, right? That's going to give me a positive 10. Now, clearly, I still have this minus 0, but you can see if we add 0 to both sides, that's not going to change anything, right? So my equation is going to be negative y equals negative 5/4 x plus 10. Voila. All right, these last few, notice the last few, there we go. These are kind of the oddball ones, which I would suggest drawing a picture for, unless you're really aware of what the vertical and horizontal lines are all doing on your graph. So anytime it mentions the word axis, let me highlight that right here. Anytime it mentions the word axis, I would definitely sketch the graph, right? So here we go. I'm going to sketch the graph. Well, that didn't straighten that line for me. Let's get a straighter line. There we go. All right, so here's my graph. It wants us to go through the point 6, negative 2. Okay, 1, 2, 3, 4, 5, 6, down 2. So here's the point 6, negative 2 right there. Please also keep in mind, this is the x-axis, this is the y-axis. Okay, it wants us to be parallel to the x-axis. Okay, well, if I'm parallel, here's the x-axis right here. I want to run parallel to him, which means my line must also be horizontal, just like the x-axis. So we want the equation of that line. Well, he's a horizontal line. And what axis is he crossing? He's only crossing the y-axis at what value? Negative 2. Of course it's negative 2 because that's the y value of the point that we passed through. And that's it. right? You don't have to do any point slope because these are all going to be vertical, horizontal lines. These are all kind of the weird ones. So you don't have to do any point slope form, slope intercept form, any of that kind of stuff, right? You're just going to sketch the picture and write the equation of the horizontal line. Okay? All right. Let's go to the next problem. Now, this one doesn't mention the word axis, but it does give me a special line, right? That is clearly either vertical or horizontal. So I'm going to sketch him also. Okay, so here we go. It's just a quick, easy little sketch. All right, so remember, here's my x-axis, here's my y-axis. They want us to be perpendicular to the line y equals 4. 1, 2, 3, 4. So here's the line y equals 4. It kind of veered off on me there, sorry. Is that like, okay. He's looking kind of crooked to me. Oh, I think it's because my x-axis is crooked. Sorry, I can't deal with that. I'm going to have to fix it. Is that straight? That looks better. Okay. Sorry. I don't want my lines to look all off. Okay, so this is the line y equals 4, crossing the y-axis at positive 4. Okay, so we want to be perpendicular to that line. So clearly, any line perpendicular to it is going to run vertical, right? And we want to pass through the point 3, 7. Okay, 1, 2, 3, and that was already 4, so 5, 6, 7. So we want to pass through this point right here, 3, 7. So perpendicular to y equals 4, but containing the point 3, 7. Let me put my point over a little bit more. So we're going to be this line right here, which is a vertical line. Right here's the right angle, perpendicular, right? It's a vertical line, which means he's only crossing the x-axis. And where is he crossing the x-axis? At 3. Of course it's crossing at 3 because that's the x value of the coordinate that we're passing through, right? And so our answer is just x equals 3. I don't need to do any fancy work, and I actually can't do any work because remember, x equals 3 is not even a function, right? So I wouldn't even be able to do any work. I have to kind of understand the sketch behind that. All right, last two really quick. Notice this one is kind of similar to number 13, right? It says parallel to the y-axis. So again, anytime you see the word axis in these problems, I would sketch the graph. All right, so here we go. Let's see if I get my lines straight the first time around here. All right, there we go. Actually, he looks kind of crooked. Okay, so there's our x-axis, there's our y-axis. All right, we have to be containing the point -1, 7. Okay, -1, 1, 2, 3, 4, 5, 6, 7. All right, so here's the point -1, 7 right there. And we want to be parallel to the y-axis. Well, here's the y-axis. So if I want to run parallel to the y-axis, then I need to be a vertical line. So you just need to recognize, oh, it's a vertical line, which means he's only allowed to cross the x-axis at -1, which means that is his equation, x equals -1, which makes total sense because, again, -1 is the x coordinate there. Okay, so just draw yourself a quick sketch. All right, last one. Perpendicular to the line x equals 3, which is clearly not a normal line. So again, when I see that, I'm going to sketch the graph for myself. All right, so here we go. Maybe. Sorry, my Apple Pencil keeps kind of stuttering. Okay, so here's my x-axis, here's my y-axis. They want us to go through the point 5, 8. So if you want to go ahead and plot that point, you certainly can. 1, 2, 3, 4, 5. So we're going right 5, and 1, 2, 3, 4, 5, 6, 7, 8. So right 5, up 8. So we're wanting to go through this point right there. But we also want it to be perpendicular to the line x equals 3. So not an axis, but x equals 3. So remember, that's a vertical line crossing only the x-axis at 3. All right, so if I want to be perpendicular to that pink line, then that means my line needs to run horizontal. And I just need to write the equation of that horizontal line. Well, horizontal lines are only allowed to cross the y-axis at, and this one's crossing at 8, which is very clear because that's our y-coordinate. And so that is our answer. All right, I'm going to stop this video here since that's the end of the day 1 stuff. And then I'll pick up with another video for day 2 stuff.